So I'm going to show an example of finding the area between two curves. This is an example video, so if you're looking for more of an explanation as to like how this works and why this works, I would check out my lesson video on the same topic. I'm just going to go straight through a second example because this is just an add-on to my lesson. Okay, so we want to find the area between the curves y equals x squared minus 2x and y equals negative x squared plus 4x. So the first thing that I'm going to tell you is to graph it. And I know that this is kind of the challenging part, so I do want to really encourage you to pause the video and try to graph this totally on your own. Even if you just struggle with it and you don't get that far, it's better to struggle a little bit before you watch the solution versus watching me do the solution. So hold yourself to that standard. Hit play when you're ready. Okay, so let's say that I'm trying to figure out what the graph of x squared minus 2x looks like, and I'm not really sure. Well, an easy way to figure that out is to figure out some points, and some of the easiest points that you can figure out would be found by setting that function equal to 0 and solving it. So I'm basically setting my y coordinate equal to 0, and then I can easily solve this by factoring out the x. So then I'm left with x times x minus 2 equals 0. And so this produces two solutions, either x equals 0, which gives me the point 0, 0, or x equals 2, so that'll give me the point 2, 0. So I can go ahead and set up my graph, and I can plot those 2 points. Now, if I feel like that's not enough, you can always just grab a couple more points, right? I know that this is supposed to be a parabola. I'm just maybe not confident as to where it's going to bottom out. So the next thing that I'll do is, so I've got the points 0, 0, and 2, 0. So why don't I plug in the point in between, this 1, 0? If I plug that into my function 1 squared minus 2x, x squared minus 2x. If I plug that in, here's my calculation. So I'll get the point 1, negative 1. So I've just really figured out 3 points of this function to make the parabola. And now I can go ahead and there's my first function, x squared minus 2x. Okay, and so we can repeat that now with negative x squared plus 4x. Now, if you watched me draw the first one, I strongly, strongly recommend that you try to draw the second one totally on your own. Again, you've got to know how to kind of struggle through this. That is kind of part of the process, is figuring out what the heck does this look like. Hit play when you're ready. So once again, I'm going to just set that function equal to 0. I'm going to factor out the negative x, and so I get the points 0, 0, and 4, 0. So I can go ahead and plot those points here. So I've plotted those in blue. I'll plot the second function in blue. And then once again, so I know that this is going to be a parabola. So since this is negative x squared, I know this will be a parabola that opens downwards. When it's got a positive x squared, it opens up. When it's got a negative x squared, it'll open downwards. So I know that, but I just don't know maybe where the top of it's going to be. So I'll just choose a point in between 0, 0, and 4, 0. So I'll just choose this point here, which is 2, 0. And I'll plug that in. And I just plug it straight into the function. Just calculate it out, and I get 2, 4. Okay, so my second function looks like this. Okay, and so we're trying to get the area between the curves, so we want this area here. Okay, so I need to know what are the points of intersection. I know one of them because I found them. I found that both of these have the point 0, 0. And then I just need to find the other point of intersection, which I can do by taking the two functions and just setting them equal to one another, like you see here. And then you can go through and just do the algebra to solve this. So again, I would recommend that you just try to engage with the video and just try to find the other points of intersection on your own before you watch the solution. Okay, so in doing that, so I'm going to bring all of my x's over to one side, and then I've got everything equal to 0. I can factor out the 2x as you see here, and so then I've got x equals 0 and x equals 3. So x equals 0 was this point here. This is going to be where x equals 3. And so if I just plug 3 into, it doesn't matter, I can plug it into either one of these functions. If I plug 3 into one of these functions, I find that I've got the point 3, 3. Now, just for the sake of completeness, I like to usually know what this other coordinate is, though it's not always important that you know what the y part of the coordinate is. I just like it for completeness. Okay, so now we're good to go. We've got everything that we need. So to set up our integral, I just need to know what's my top and bottom function. So the blue function is on top, the white function is on the bottom. So I'm going to take the negative x squared plus 4x, that goes first, minus x squared minus 2x, that goes second. And then my limits of integration, so those go from the the highest x value to the lowest x value, since this is an integral entirely in terms of x. So my limits of integration go from 0 to 3. So here's my integral now, and now I don't need my picture anymore. So now I just need to go through and I just need to collect my like terms. So if I simplify this, this will actually shake out to be negative 2x squared plus 6x. And then I can just integrate this like normal. So this is just a nice basic integral. So I integrate, I get negative 2 over 3x cubed plus 6 over 2x squared. 6 over 2, of course, can be rewritten as 3, so I'll write that in the next part of my calculation. And from here, this is just a matter now of plugging in your limits of integration, as you see here. So I go through, I plug everything in, and you can pause the video to inspect my work, but when I work all of this out, I get that this works out to 9. Okay, so that's the basic idea when you've got everything in terms of x, so I'll leave it at that. And I do have some other example videos that you can check out, and if you ever have a request, you can always leave me a comment, and if I have time, I will make a video for it. Thanks for watching, guys.